Hello, everyone. This is VR4ALL, the educational toolkit for VR learners. I'm very happy to present the new progress for this project. So, at the beginning, to just recap, I want to recap it with a recent video. So, I will play this video. You will see. This is a really amazing moment for this VR stuff. As you can see, when I wear the VR stuff, the VR headset, it successfully combined the IMU inertial measurement unit with this, and we successfully also combine using the IMU logic to control the graphics thing, as you can see here. So based on the head rotation, the graphic things would also change. So this actually build up to make the whole pipeline work, connecting the both graphics and the hardware. So very exciting. So then you will know what they are for. So the progress. So to summarize, since like we are actually in a stage of combining both the hardware and software, so this time I won't talk about the progress separately. So I want to talk it in the whole. So first, we read the real-time the IMU data from the serial port sent by Tencent 4.1. So this is not trivial on the Mac computer, since the Mac doesn't have the serial port. So usually you will use a USB hub, but to read in the real time, the USB hot buffer stuff is different with the Tencent board buffer size. So there will be a lot of issue on like actually making this happen. And also control using the IMU data to control the camera rotation graphics, which is also not a trivial stuff. In the meantime, we successfully like sourced the 5.5 new in like high resolution screen, the new screen, and we combining the system. And we migrate the whole system to the standalone Laboratory mini computer. So which means that now you don't need any cables. You can just wear that VR glasses rather than connecting them, hook up them with your computer. So this is actually I would say like if you're see the like the similar courses taught in Stanford or U Washington, they actually using the laptop as a processor. But now we firstly like make the whole system on a standalone mini computer, which is pretty exciting. And also we try to analyze the latency using the Chrome performance profile. So we increase the FPS from 1 to 11 using approximate thing with less polygons. So as you can see here, the frame, like the PF, the FPS here is not ideal here because like the GPU of the library computer is pretty like in a kind of like low end of the market. So it is definitely not that powerful to handle it. So you may ask the question like, how do you know that? And probably it's due to your rendering program. So we later do an analysis on this, and I think we will come up a good solution on the GPU hardware pro improvement solution. Well, I will present the form. I do the survey. I did the survey at the end of the presentation. So the design choice modification comparing with the last presentation we made. So we definitely replaced the 7-inch display for Pi from Adafruit to a more high resolution, high quality, um, like a more compact display, 5.5-inch display. It is has like 1000 by 2000 resolution almost. So this is very high resolution, and you won't see the pixel grade after you will the magnifier lens with your VR. And we also try to resync the level computer. We actually compare the GPU of several off-the-shelf pretty popular mini computer. I will demo that later in the forum. And also we review the graphic rendering pipeline to make it render faster by decreasing the number of the polygons. So one thing new here for me is how to really analyze the WebGL rendering latency. So it turns out you can do that by using a Google Chrome, browser. They have some like performance profile stuff. Just record a part of your like rendering, rendering things, and you can actually analyze this. As you can see, the function tree here, how much time it will take to render in one frame, and what is basically what is the function that costs such time. So we are actually trying to shrink down to really, really simple things, and still you can see here for each frame is roughly also cost like 100 microsecond to render. So which made the whole frame per second to like 10, around like 10. So this is a really helpful tutorial. If you want to dig into more about this topic, you can definitely have a look in this link. The interview feedback, I think overall, like we interviewed 2 different persons. So I think both of them are agree that this is a good exploration on the latency part, because we never tried that before on a really standalone computer, even for the other university that teach this course. But we have such like conflicts on the necessity of the improvement. One of the interviewer, he think about from the course teaching purpose, right? So like course teaching, you want to expose the problem to students to trigger the thinking of this problem. And also you have the limited budget for each group. If you go to a more advanced option for the mini computer, which will cost more, like $100 more, so which will hurt the budget, and also make the VR4 more like VR4 kind of like rich people. But product perspective, some of the interviewer mentioned that they really want a usable product rather than a product that is just rendering in 10 frames per second, which strong latency you will feel. So they will be happy to have a 30 frame per second product. So actually there's a conflict. This comes to the question I want to ask for the audience. So if you're a student of that course, what do you think? Do you want to have a more powerful mini computer, to make the rendering stuff easier, or you prefer that keep the budget and make this problem exposed and try to trigger more improvement on this? What do you think? And I think the second question for me is later, I think I will add up the ESP32 camera module to the system. So I think we use it in the E326 before for Lux Quarter. I think there's an optional part like how do you further improve the frame per second, the frame rate for the camera. So I think the original one will be roughly like 9. How would you actually make it go beyond the 10? What kind of like the technique or trick you use to increase the frame rate for the camera? Okay, so this is the form I made about the comparison the current off-the-shelf market. Raspberry Pi 3, 4, Labro, Orange Pi, Tinkerboard, and NVIDIA Jensen Nano. So especially if you look into their GPU perspective, you will basically see the Jensen Nano will be roughly like 10 times more advanced or faster than roughly the Labra computer, or roughly like 5 times or 6 times, 10 times than the Raspberry Pi 3B. So if the frame per second for the Labro is 10, probably NVIDIA Jetson could do 50. So which is a huge improvement and could handle such requirement. Okay, thank you. I'm very looking forward to your question and answers. Thank you. And also, if you're interested in this summer course, now the enrollment is beginning, so you can actually start with this. Thank you.